Well, class, I want to cover the next section, which is section 2.8, 2.6, limits involving infinity. So let's begin. And definition, let f be a function defined on an interval from the open interval from a to infinity. Then the limit as x goes to infinity of f of x equal L means that the value of f of x can be made arbitrarily close to L by taking x sufficiently large. And this is the definition we've already had for what it means for a limit to exist. Now, if we look at this next definition, it says let f be a function defined on some interval from negative infinity to a. Then the limit as x goes to negative infinity of f of x equal L means that the values of f of x can be made arbitrarily close to L by taking x sufficiently large but negative. So these are talking about a limit existing. But what is different here is what x is going to. X is not going to a number. X is going to infinity in this definition, and x is going to negative infinity in the other definition. So we're talking about limits involving infinity. So we're either going to be talking about when x is going to infinity or negative infinity, or when our answer is infinity or negative infinity. So let's look at an example of this. Bring this down a little bit. And we have f of x equals 1 over x squared. And we want to look at the limit as x goes to infinity of 1 over x squared. Now, we can look at this on our calculator. And this is one of the graphs that we should already be familiar with, from college algebra. This is a rational function. And if we look at this, let me bring this over where you can see it. And we go 1 divided by x squared. We see that it looks like this. It has a vertical asymptote right there. That vertical asymptote is at x equals 0 because the denominator cannot be 0. But look at what's happening over here and over here. These are both horizontal asymptotes. So this one is as x goes to infinity. And this one is as x goes to negative infinity because we're going out this way. We're going out in the positive direction and going out, out, out. This way, we're going out in the negative direction, going out, out, out. And so horizontal asymptote. So what that means is that the y value gets closer and closer to this line, which is the x-axis, but it never reaches it. So y gets closer and closer to being 0, but it never reaches it. Sorry about my finger. This is some bad arthritis that I have, and I know it's an ugly witch finger, but there ain't anything I can do about it, so I'm sorry. But anyways, I should probably put something on top of it so you don't have to look at it. But anyways, so what we're talking about here, let me just sketch in the little picture. It looks kind of like this. And kind of like this. Except it should be, mirror image on each side. So y equals 0 is what we call a horizontal asymptote. Okay, so this is equal to 0. And the limit as x goes to negative infinity of 1 over x squared is also equal to 0. Now, you need to remember this really, or remember this concept. This is what I want you to remember. If you've got the denominator getting bigger and bigger, either going to infinity or negative infinity, and the numerator is a constant, then it's going to be 0, okay? Because you think about it, whenever you take a number, and the number could be 1,000,000, but if you're dividing by something that's getting infinitely large, the whole thing is going to get smaller and smaller. I mean, think about if we've got a pizza and people keep coming into the room, the more and more people to eat our pizza, our slices, which is like, like a fraction of the pizza, are going to get smaller and smaller, and they're actually headed towards zero. Because remember, this doesn't mean, well, X never would be infinity or negative infinity. This just means approaching infinity or negative infinity. Doesn't matter which way. And in this example, it's X squared. So the numbers are getting more and more negative, but they're getting squared. So the denominator is getting bigger and bigger and positive. And so they're both going to zero. Okay, and that's important to remember that concept. This is important also to remember in Calculus 1. So just remember this in Calculus 2. Okay, so what we're saying down here, the line y equal L is called a horizontal asymptote of the curve y equal f of x. Either the limit as x goes to infinity of f of x equal L, or the limit as x goes to negative infinity of f of x equal L. So we've got two horizontal asymptotes here. They're both y equals 0, but there's one going out this way and there's one going out this way. So that's what we're talking about with horizontal asymptotes. Okay, let's go to the next page. Get this set up for us. Yeah, I think I'm gonna get in a little bit closer. Okay. So we've got for the function g, whose graph is given, state the following. So we're going to state some limits here. Maybe I'll make it darker. This is saying x going to infinity. So in case you can't read it, because it's kind of like that's saying x going to infinity right there. And this one's saying x going to negative infinity. And this one is saying x going to 3. And this is saying x going to negative 2 from the plus side. And this one is saying x going to 0. And then we have to find the equations of the asymptotes. So we want to look down here. Now, when we're talking about x going to infinity, we want to look right here. And also going out this way. Okay. So what we want to see is if there is a horizontal asymptote here. It could be that there's not a horizontal asymptote and the graph either goes up or down to negative infinity or positive infinity. But in this case, when you see the graph, which means the y value, getting more and more linear, so it's starting to look like a straight line. It isn't actually a straight line, but it's getting closer to a straight line. That means there's a horizontal asymptote. And what that means is that whatever that y value is, and in this case, let's see, it's 1, 2, is it y equal 2? That's what the limit is, because remember, if the limit as x goes to infinity is some number, that's the horizontal asymptote, and this number happens to be 2. Okay, so now let's look at going out the other way. This does look like it's getting linear. It's kind of hard to tell, but it is getting linear. So if it would keep going like this. And sometimes you might have to look at your calculator and go on out some to see what's happening. So this is y equal negative 2. Oops. Y equal negative 2. 1, 2, and this is as x is going to negative infinity. So that's x going to negative infinity. This is x going to positive infinity. So this is also a horizontal asymptote. Now, just because there's a horizontal asymptote at one side of the graph doesn't mean that there has to be one on the other side. It might have two. It might be going to one thing on this side and a different thing on this side, like in this case. It could be going to the same number on both sides, like in the previous case, or it could be doing completely different things and not even have a horizontal asymptote on both sides. So anyways, as we're going to negative infinity, we're going to -2. Now this says the limit as x goes to 3. So we look at over here where 3 is. What's happening there? Wish y'all could answer me. But what's happening here is we can tell that's a vertical asymptote. You can tell it's a vertical asymptote if either on the right or the left, if either one of them is going to infinity or negative infinity. So it looks like this is just going on up. So the y is going to infinity here. And the y is also going to infinity on the other side. Now they don't have to be doing the same thing on both sides, but the y value is going up, up, up. And that's what we call, so that's going to be x equal 3. That's a vertical asymptote. Okay, so the question was, what's happening if x goes to 3? Well, since on both sides we're going to infinity, we can just say infinity. Now, if you remember, the limit doesn't actually exist if our answer is infinity. Now, like right here, our answer is -2 and 2. So those limits do exist. But if our answer is infinity or negative infinity, that means the limit does not exist. Okay, and so then we look as x goes to 0. So here's one side and here's the other side. Now, what does that look like? Is it an asymptote? If so, what kind of asymptote? Well, it's a vertical asymptote. So that's at x equals 0. That's a vertical asymptote, and I'll just abbreviate VA. So what's happening then, as x goes to 0, since both sides are going down, 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 so the y is going down. And the y is going, y is going down, the y is going down. So going down means going to negative infinity. Going up, up, up means it's going to positive infinity. Okay, so for my answer up here then, what's happening? It's negative infinity. Now, you might have a question of how do I know whether I say that the limit does not exist or I say infinity or negative infinity. On the test, I will tell you if the answers can be infinity or negative infinity. So I'll say like answers may include infinity or negative infinity. And then you'll know that if it's going up, 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 the limit really doesn't exist, but you can say infinity, or down, 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 you can say negative infinity. Now the limit as x goes to -2 from the positive side. So let's see, -2. What am I? Oh, okay. Let's see. This is the weird thing. This is my axis right here. But sometimes I can't find it. So this is actually -1, -2. So if we're talking about coming in from the positive side of -2, we're actually talking about, I'm going to erase this right here because it's not as important as what I'm about to draw. Okay. So we're coming in from the positive side. So we're coming in like right here to this other side of that vertical asymptote. Okay, so what's happening at that vertical asymptote? It's going to negative infinity. We just said that. So if we're coming in from the positive side, we're coming in, or you're coming in from to -2 from the positive side. It's not over here. It's really right here. Okay, and if we look, so x is approaching -2 from the positive side right here. It's going down, down, down. And then the other question is the equations of the asymptotes. Let's just write it. Where do I want to write it? Some room to write it. Let's just write them right here. So the vertical asymptotes let's look at what we've got there. We had a vertical asymptote right here at x equal -2. So I'm just going to start and go left to right. So at x equal -2, you see there isn't a vertical asymptote on this side, but there is on this side. And then we have another one at x equals 0. And then we have another one at x equal 3. Now, the horizontal asymptotes, let's see what I'm writing. Okay, the horizontal asymptotes and remember, for the horizontal asymptote, we're talking about what's happening as we go out to the ends of the graph, going out to infinity this way. The y value is approaching 2. So we had y equal 2, and going out to -infinity this way, we had y equal -2. And another thing to remember, your vertical asymptotes are going to go x equal because they're vertical, and the equation of a vertical line is x equal. The horizontal asymptotes are going to go y equal because they're horizontal lines, and horizontal lines go y equal. Now let me just pull back and let you look at that for just a minute and kind of let this sink in a little bit. Okay. So there, these were limits involving infinity, because either x is going to infinity or negative infinity, or the answer was infinity or negative infinity. Okay. If we were in class, I would say, any questions about that? But can't do that now. So let's go to the next page. Guys, you know, when you're going through this, take your notes, and if there's something you don't understand, and you can print the notes, you know, from iCollege. But if there's something you don't understand, just send me an email. Y'all have been being pretty good about asking WebAssign questions. So that's good. I want you, you know, it's an online class, so you need to be talking to me for this to be successful. Okay, so I've got f of x equals 1 over x cubed minus 1. And like on a test, it would say something like this. Answers can be infinity or negative infinity. Okay, I want to find the limits. Okay, so the first one, I've got the limit as x goes to 1 from the negative side of this function, 1 over x cubed minus 1. Okay, so I can figure this out without having to graph it. But of course, I could graph it as well. So this is 1 over x cubed, that's a cube, minus 1. If you think about it, x is going to 1, but it's less than 1. So x is going to 1, but is less than 1. That's what that minus sign means right there. So if I cube something less than 1, x cubed is going to be also less than 1. And if I cube a number, it's gonna, and the number's less than some number, then that cube is gonna be less than the cube of that number. So what's gonna happen here is I'm taking something that's less than 1, and then I'm subtracting 1 from it. So, and this is gonna be, let's see, it's less than 1, it's a positive 1. So this is going to 1, but it's less than 1. And then you're subtracting 1. What's happening is the denominator is getting closer to 0, and it's negative. Okay, I need to pay attention to that because I need to know, remember, well, maybe we didn't actually talk about this, but if your denominator is getting smaller and smaller and you're dividing some number by something that's getting smaller and smaller, then the whole thing's either going to go to infinity or negative infinity. And I think we've got a little theorem about that in a minute. Yeah, we do. But I'll just write it down here anyways, because this is really important that you remember. If you've got a limit and x is going to some value, and we've got some constant number, and we're and or let's just say x is going to infinity here. We've got x in the bottom, that's going to be 0. Okay, so if you're taking a number and dividing it by something that's getting bigger and bigger, it's going to be 0. Yeah, we did already talk about that. And if we've got the limit as x goes to negative infinity, now I'm all messed up. I hate this when I'm all lopsided. Okay, and we've got a constant, doesn't matter how big the constant is, then and we're going to negative infinity, then, well, actually that is also going to be 0. But no, this is what we want to talk about, and we haven't talked about it. If we've got the limit as x goes to 0, and let's talk about from the plus side of a constant over x, then that's going to go to positive infinity. But if we've got the limit as x goes to negative infinity of a constant over x, then that's going to go negative infinity. This should be 0 from the negative side. And that's going to be negative infinity. So you see, what we need, we can tell that this denominator is getting closer and closer to 0. So my answer is going to be either infinity or negative infinity. But what we need to figure out, is it coming into 0 and negative, or is it coming into 0 and positive? Because if it's coming into 0 and it's negative, then that means it's going to be negative infinity. But if it's coming into 0 and it's positive, then that means it's going to be positive infinity. So what we've got here, it's getting closer to 0 in the denominator, and the numerator is just plain old 1. So what you got is, it's hard working from home sometimes. So we've got a fixed number. It doesn't matter if it's 1 or a million, but this is getting closer and closer to being 0, this whole thing. And so it's getting closer and closer to being 0 because this is getting closer and closer to 1, but its numbers less than 1. So like 0.99, 0.99 minus 1 is going to be negative. It's getting closer to 0, the whole thing here, but it's negative. So what this is going to be, this limit, the limit as x goes to 1 from the negative side of 1 over x cubed minus 1 is going to be a negative infinity. Okay, now we explained all that. You could look at this on the calculator. Let's look at it on the calculator. Okay, so let me go back to my y equal. Turn on, go back to my y equal. Let's get rid of this one. And this was 1 divided by, and guys, you got to use your parentheses, x cubed, and get down out of the exponent minus 1. Okay, and you see we're approaching 0 from the minus sign, or actually, no, I'm sorry. It's not 0, it's 1 right there. So x is approaching 1, and it's approaching it from less than 1, and you see it's going down to negative infinity. Here it's approaching 1, and it's approaching from greater than 1, and it's going up to positive infinity. Okay, so I'll just draw a little picture right here so we remember. You can graph it yourself. On your calculator, that's a big tool, isn't it? And it looked like this. This is 1. And it was going kind of like this, getting closer, going up, as I didn't draw that right. It should be over here, getting closer and closer to 1 from the positive side. Okay, there is a vertical asymptote there. It's getting closer and closer to 1 from the positive side, and then it's getting closer and closer to 1 from the negative side. Okay, let's see what we've got next. Okay, this is just what we were talking about. If the limit as x goes to infinity of 1 over x to the r, to any exponent that is a rational number, and it's positive, it has to be positive too. If it was negative, that wouldn't be true. This wouldn't be true. But if you've got a positive exponent, and we've got 1 over, and x to the r is in the denominator, what's happening if x is going to infinity, this thing's getting bigger and bigger. The denominator's getting bigger and bigger. So that's going to be 0. And if you're going to negative infinity, it's also going to be 0. And here's just another example. Okay, so let's let f of x equal 1 over x. And this is the most basic of the rational numbers. Then the limit as x goes to infinity of 1 over x equals 0. And the limit as x goes to negative infinity of 1 over x equals 0. Because you're taking a set number and you're dividing by something that's getting bigger and bigger. It doesn't matter as long as that x is a positive exponent. So like 1 over x cubed as x goes to infinity of 1 over x cubed, that is also going to be equal to 0. And also, the limit as x goes to infinity of 1 over the square root of x is going to be 0. Because, you know, you can think of the square root of x with an exponent, the limit as x goes to infinity of 1 over x to the 1/2. Same thing. Okay, let me think if there's something else I need to tell you about. Now, x wouldn't be going to, well, never mind. Let's just move on to the next thing. Okay, so we've got an example. We want to find the limit. And it's the limit as x goes to negative infinity of 1 minus 2x squared minus x to the 4th over 5 plus x minus 3x to the 4th. So what we've got is we've got a polynomial divided by another polynomial. So what we do, if we have a polynomial in the numerator and a polynomial in the denominator, then and if x is going to infinity or x is going to negative infinity. Now be careful because you don't want to do this if x is going like to 2 or 3 or something. Only if x is going to infinity or x is going to negative infinity. What we want to do is we want to divide the numerator and denominator by the highest power of x. Okay, in this case, the highest power is x to the 4th. So I'm going to go ahead and write this all out this time, and then I'll show you an easier way to do this. But this is really what it comes down to. You divide every term by x to the 4th. And then we're going to simplify it. Simplifying when we're dividing like bases. So this is going to be the limit as x goes to negative infinity. And so we've got the 1 over x to the 4th. We've got, this is going to give me a 2 over x squared. So I'll write them all slanted like that. Like that. And then we've got minus 1. Okay, in the bottom, we've got 5 over x to the 4th minus 2 over, minus, that's going to be 1 over x cubed. And then this will reduce to 3. Okay, if x is going to 0, remember the theorem that we just wrote up there? If you're dividing a constant number in like 1 or 2 or a million or whatever, if your denominator is getting bigger and bigger, either in the negative way or in the positive way, then it's going to go to 0. So this is going to go to 0, and this is going to go to 0, and this is going to go to 0, and this is going to go to 0. So the only thing that we're going to have left is a -1, and it's a -1 over a -3. So that's going to be 1/3. That's what the limit is going to. What we used here, when we use this when we've got a poly over a poly, we use the limit as x goes to -infinity of 1 over x to the r equals 0. So you've got to remember this to make any of this work, okay? Now, also, we have a horizontal asymptote. It means that we have a horizontal asymptote. And what the horizontal asymptote is, it's y equal 1/3. Okay, if you remember back from pre-cal, remember that if you're looking at a poly over a poly and you're looking for the horizontal asymptote. So you're looking out, near the ends of the graph, either in this case, it would be going out to the left because we're going to -infinity. But if we're looking for a horizontal asymptote, then remember if the power is the same in the numerator and the denominator, the highest power is the same, which it is in this case. It's x to the 4th and it's x to the 4th. Then what's going to end up happening is it's going to be the ratio of the coefficient here divided by the ratio of the coefficient here. So that's how we get the 1 over 3 or the -1 over -3. Now, let me just write a little cautionary statement right here. Only divide by the highest power of x, or whatever your variable is, when x is either going to infinity or x is going to -infinity. So if we've got x going to 2 or 3 or something, we don't do that. And then this is just a statement from pre-cal, because you can use it. You don't have to go through all of this. I mean, actually dividing by the highest power. You can just use the thing from pre-cal, which says if the degree of the numerator equals the degree of the denominator, then the limit as x goes to infinity or -infinity of f of x equals L, where L equals the leading coefficient in the numerator over the leading coefficient in the denominator. And by leading, we mean the coefficient of the highest x, the variable with the highest exponent. Okay, so that's that example. Let's just take a quick look at it again. So you see what we did. We had a poly over a poly. We divided by the highest power of x, and then we simplify it to see what's left. And then if you've got a constant in the top and x going to x in the bottom, and x is going to either -infinity or positive infinity, then these are all going to go to 0, and then it leaves this -1 over -3, or 1/3. Okay. Another example. I'm going to do a few examples here. Okay, so we want to find the limit. And so we've got the limit as x goes to infinity, so positive infinity, of x plus 2 over the square root of 4x squared plus 1. Okay, the highest power of x in this problem right, is actually the square root of x squared, which is x. And since x is going to infinity, we know it's positive x. It's a positive number because x is positive if x is going to infinity. And so, you know, this simplifies into, if you think about what the power is going to be down here, it's going to be just plain old x, or x to the first. That's the same power that we have in the numerator. So I'll do this one more time. I'll go through the steps of really dividing it out. But next time I probably won't, because I'll just look at what we have here and I can figure out what the answer is. So divide every term by x. You know how I can figure out what it is? The coefficient. Since they actually have the highest power is x to the first in the numerator and the denominator, so that's the same. The coefficient here is a 1. The coefficient down here would be the square root of 4, which is 2. So my answer is going to end up being 1/2. But let's see, divide every term by x. Okay, so let's do that. And so what it's going to look like, limit as x goes to infinity of x over x plus 2 over x. And then when we're multiplying inside the square root, we have to divide, or when we're dividing inside the square root, we have to divide by x squared inside the square root. Okay, why is that? Well, the square root of x squared would be x. If we divide by x in here, we're really dividing by the square root of x, not by x. So this will simplify. This will be a 1. This will be a 4. And this will be 1 over x squared. Now, remember, this is going to go to 0, and this is going to go to 0. So I have 1 over 2. And I told you that that was going to be the answer because I can look at it, which you really don't have to go through all this dividing. And I know that this is going to simplify. Well, I mean, I can't just take the square root of this and the square root of this, but what's going to happen? This term is going to go to 0, and this term is going to go to 0. And so then I take the square root of 4x squared. That's going to give me 2x. So the coefficient here is 1. The coefficient down here would be 2. And so the answer is 1/2. And that's what my limit is. Okay, let's see. What else? Okay. Let's do another example. Okay, I'll do all 3 of these cases. So if on this page. Let's find the limit And we've got the limit as x goes to infinity of x plus 1 over x cubed plus 2. Now, we can go ahead and do our dividing. Then why don't I just show you? So the highest power of x is x cubed. So if I divide x by x cubed and the 1 by x cubed and the x cubed by x cubed and the 2 by x cubed, well, I know this is going to go to 0, and this is going to go to 0, and this is going to go to 0 because it's going to reduce to 1 over x squared. And this is going to go to 1. So really what we're going to have is the limit as x goes to 0 of 0, or x goes to infinity, I mean, of 0 over 1, which is just 0 over 1. But what is 0 over 1? Well, it's 0. Okay, so there is a horizontal asymptote. And it's y equals 0. Now, the thing to remember here, like for pre-calc, same thing, if the degree of the numerator is less than the degree of the denominator, then the limit as x goes to infinity or negative infinity of f of x is going to be 0. So that's like if with the horizontal asymptote, if there's more x in the bottom than in the top, then it's going to go, the horizontal asymptote is going to be y equals 0. Okay, so the numerator is less than the degree of the denominator, x is going to infinity or negative infinity. That means that the denominator is getting bigger faster than the numerator. And so you're dividing something that would reduce to some constant by something that's getting bigger and bigger and bigger. So that's going to be 0. Okay, let's do the other example as well. Maybe I'll just do it right here. So I want to find the limit, and I've got the limit as x goes to infinity of x cubed plus 2x over x plus 1. Okay, what's the highest power of x? It's x cubed. So you could go ahead and do that step. And so we'll have x cubed divided by x cubed plus a 2x divided by x cubed plus a x over x cubed plus a 1 over x cubed. So we can just go ahead and use what we know. This has more x in the bottom, and x is going to infinity or negative infinity. So that's going to go to 0. That's going to go to 0. That's going to go to 0. And this is going to be 1. So really what we have then is the top is going to 1. And the bottom is going to 0. The bottom's getting smaller and smaller because remember, we're talking about a limit. Well, what is 1 divided by 0? Well, it's undefined, isn't it? But we're talking about a limit. So we're talking about 1 being divided by a number that's getting closer and closer to 0. So what that means, if this is getting smaller and smaller and you've got a constant up here, that means that the limit is going to be going to either infinity or negative infinity. So in this case, it's infinity. And so really, that's my crazy looking infinity. The limit does not exist really. But if the problem says answers may include infinity and negative infinity, then the answer is that it's infinity. Now, this just goes back, and so there is no horizontal asymptote. because really what the horizontal asymptote is it's the limit. It's just in trigonometry, you don't know about limits yet. So there is no horizontal asymptote. So we saw the case when the degree of the numerator and the degree of the denominator were the same. We saw the case when the degree of the denominator was greater than the degree of the numerator. And now we've got the degree of the numerator is less than the degree of the denominator. Okay, then what that means is the limit as x goes to infinity of f of x is going to go to infinity. Because you've got more on the top than on the bottom. So it's going to end up just getting bigger and bigger in either the positive way or the negative way. Okay, now let's look at another example. Got another theorem. Theorem. Maybe it's a definition. I'm not sure. But anyways, the limit as x goes to negative infinity. So let me just write it out again. Of e to the x equals 0. Now, if you were talking about the limit as x goes to positive infinity, that would mean the exponent's getting bigger and bigger, and e to something getting bigger and bigger is going to get bigger and bigger. So that would be infinity. But if x is going to negative infinity, then what's happening is this exponent is getting bigger and bigger in the negative way. And remember what that means. So like the limit as x goes to infinity or negative infinity. Of e to the x is the same thing as the limit as x goes to infinity of 1 over e to the x. Because what's happening, if your exponent's getting bigger and bigger in the negative way, if you remember what the negative exponent means, it means 1 over whatever the thing is, in this case, e to the x. So what would be happening here is the bottom would be getting bigger and bigger. The bottom would be going to infinity, and the top is just 1. So what that means, it's going to be 0. Okay, so and we can look at our calculator. See if I can find mine. So if I look at the graph of y equal e to the x, and so there's a place for the number e. It's right over here before the division symbol. Right over here before the division symbol. So you have to hit the blue key, and then you have to hit the e. So what I'm going to put in here is e to the x. So I'm going to go second function e, and then I'll raise that to the x. And then I hit graph. And this is what it looks like. So what we were saying was the limit as x goes to negative infinity is 0. That's where the horizontal asymptote is we're going out to negative infinity. As x is going to positive infinity, going this way, the y is just going up, up, up. So that's what we were saying right here. If we're going to negative infinity, we've got the limit's going to 0. And if we're going to positive infinity, it's going to infinity. So what we're saying here also is the horizontal asymptote would be y equals 0. Okay, so I think that's really all I need to say about that. All right. Let's do another example. So we want to find the limit if it exists. And so we're going limit as x goes to infinity of 8 minus e to the x over 8 plus 7 times e to the x. Okay, so we don't have x to a power, but we have e to the x. So divide every term by e to the x. So it's like when we were dividing by the highest power of x, but now we are dividing by e to the x. So if I were to actually go and do that, so I would have the limit as x goes to infinity of 8 divided by e to the x minus an e to the x divided by e to the x, another 8 divided by e to the x, plus a 7 e to the x over e to the x. Finish my parentheses. Okay, so what we've got here, we've got 8 over e to the x. This will become a 1. We've got 8 over e to the x, and this will become a 7. Okay, so now this is going to go to 0 because if x is getting bigger and bigger, then e to the x is getting bigger and bigger. And so this is going to go to 0 too, because remember, if what's in the denominator is getting bigger and bigger, and we've got a constant in the numerator, then that's going to go to 0. So my answer is going to be negative 1/7. So that is my answer. Okay, now let's talk about some limits involving infinity and their composite functions. So remember back to college algebra when we talked about composite functions. We talked about them a lot in Calculus 1 and in Calculus 2. So you remember, like back from college algebra, the f of g of x, or you could call that, sometimes they call it f with that little, let's like fog of x. You remember the composite, you kind of learn it near the end of, about college algebra. So for this example, I want to find the limit, and it's the limit as x goes to infinity of e to the x minus x squared, and that's it. Now, we're going to use the fact that, you know, if you know, if we've got x going to negative infinity of e to the x, then it's going to be 0. So we're going to play around with this, but first of all, let's look at the composite function. Okay, so f of x equals e to the x is the outside function. And g of x equals x minus x squared is the inside. and it's the inside function. And then the composite, we'll call it h of x, is f of g of x, which is in this case e raised to the x minus x squared. So we want to look at the inside first. Okay, so look at what's happening as x goes to infinity of x minus x squared. What is that going to be? Well, we can factor this. We can factor out an x, and it looks like this. Now, we can't really substitute in an infinity here and here, but we can think about it like this. It's going towards an infinity times a 1 minus infinity. So it's going towards a number that's getting bigger and positive. Times a number that's getting bigger and negative. Now, what happens if you multiply a negative number times a positive number? Does it come out positive or negative? Well, we all know that it comes out negative. So that's gonna go towards negative infinity. Okay, so now let's look at, we've looked at the inside function. Let's look at what the outside function does when the inside function is going to negative infinity. So we've got the limit as x goes to infinity of e to the x minus x squared. And this part is actually going to negative infinity. Now, we can actually make a substitution. Let's let you don't have to, you could just eyeball it and go, well, this is going towards e to the negative infinity, which is going to go to 0. Or you can, if you need to, which is fine, do a substitution. So let's let u equal to x minus x squared. And then as x goes to infinity, u goes to minus infinity. We already saw that, because u is this thing. And as x gets bigger, remember, u goes to negative infinity. So we can simplify this a little bit. So we'll go limit as u goes to negative infinity, because that's what u is going towards. My infinities sometimes look kind of crazy. Negative infinity, okay, of e to the u, which we know is 0. That's from the theorem. Or if you just think about it. So that means that's the answer here too. The limit as x goes to infinity of e to the x minus x squared equals 0. Because this part's going to negative infinity. So that means that we're actually, if this is going to negative, that puts this in the denominator. And it means the denominator is getting bigger and bigger. And we've got 1 in the numerator. And so that's going to give me 0. Okay. Getting close to the end. Here we go. Okay, let's look at an example when we have 2 horizontal asymptotes. Okay, straight. Okay, an example of a curve with 2 horizontal asymptotes is y equal tan inverse of x. And remember what tan inverse means from pre-calc. It's going to give us an angle. Tan inverse, like tan inverse of say 1. Or let's use a different example. tan inverse of square root of 2 over 2, for example. No, it's tangent, not cosine. What do I want it to be? Let's just go ahead and put 1. Sorry. It means what angle that gives me a tangent of 1. And so that would be pi over 4. And remember that when we're talking about tan inverse, we're talking about a restricted domain of 0 less than, let me see, is that right? No, it goes like this. It goes minus infinity, minus pi over 2 is less than x less than pi over 2. That's the restricted domain. So this is just what we're talking about here when we're talking about the tan inverse. So it gives us back an angle. Okay, so the limit as x goes to negative infinity of tan inverse of x is negative pi over 2. And the limit as x goes to infinity of tan inverse is pi over 2. So negative pi over 2 gives me negative infinity gives me a negative pi over 2. And infinity gives me a pi over 2. And here's a graph of tan inverse. So this is y equal tan inverse of x. And you notice as you go out towards negative infinity, this line is y equal negative pi over 2. And you notice there's a horizontal asymptote right here. And the horizontal asymptote is y equal negative pi over 2. And this is x going towards negative infinity. And if we look over here as x goes to positive infinity, we look out this way, my y, and this is my y is getting closer and closer to a positive pi over 2. Okay, so that's something to remember. And you can always graph tan inverse on your calculator, and you can see that, but that's something to remember. Or if you forget, just graph it. So for example, let me see if I can get this to do right. Okay. So I want to find the limit. And I've got the limit as x goes to infinity of tan inverse of x squared minus x to the 7th. So we notice and that's a 7. We notice that we have a composite function. Okay, and we want to look at what's going on with the inside. So let's see if I can just do this right here without having to write as much out. Let's factor the inside. Okay, let's just look at the inside. We can factor out an x squared, and then what we'll have is a 1 minus x to the 5th. So this is going to positive infinity, and this is going to negative infinity. So the whole thing is going to negative infinity. And then let's go ahead and make a substitution, do it like before. So let's let u equals x squared minus x to the 7th. So always remember you start on the inside, and then we can write this out, the limit as u goes to negative infinity. Because see, when x is going to infinity, u is going to negative infinity of tan inverse of u. And u is going to negative infinity right here. I wish I wrote better. So we just got to figure out what happens as it says right up here. If u is going to negative infinity, then tan inverse is going to negative pi over 2. So this is going to be a negative pi over 2. Like that. Okay. Let's take a look at it. I see the whole thing. Okay, I just got one more example. And that'll do this, that'll be the end of this section. And so here's an example. We want to find the limit. And we've got the limit as x goes to pi from numbers less than pi of the natural log of sine x. So we definitely have a composite. And so what we're going to have to do is we're going to have to do like we did before. We're going to have to start out by looking at the inside. So start with the inside. And you can either think about the graph in the XY plane, or you can think about the unit circle. It's good to be able to think both ways. So the limit as x goes to pi from numbers less than pi of sine x. Well, if you think on the unit circle, like as if I could draw a circle. So we're coming from numbers less than pi. Here's pi. And its coordinates are -1, 0. So the cosine is -1 and the sine is 0 of pi. And so we're coming to into pi, really into right here. So that's coming in from numbers less than pi. Because if you think about the angles are less than pi coming around this way. So as x goes to pi, from numbers less than pi, and I don't say left or right here because it's a unit circle, it's not the number line, then sine x is going to 0 and is positive. And it makes a difference whether it's positive or negative, because the numbers coming in here in this quadrant, quadrant 2, sine x is greater than 0. Okay, there it is. Cosine's negative, the sine's positive. Okay, so the limit as x goes to pi from numbers less than pi of sine x equals 0 coming in from the positive side. Okay, then we can do another, well, let's just look at something. So let's look at y equal natural log of x. And let's look at the graph of it. I'll graph it and then I'll just kind of sketch it in there. But if you go over here, go to your y equal screen, and you do natural log, which is this button, you know, right here. This, the natural log button's right there. Okay, so say I do natural log of x. Okay, it has a vertical asymptote at x equals 0, and it's not even defined on the other side of the y-axis. So in order to be an argument for the natural log or any log, the argument has to be greater than 0. So if you look at this, and so what we've got when we take the whole thing, we've got, and we could do a substitution, let u equal the sine x as x goes to pi from numbers less than, u goes to 0 from positive. So the limit, and it was limit as x goes to pi from numbers less than natural log of sine x. That was what our problem was. That's the same thing as the limit as u goes to 0 from the plus side, of natural log of u. Okay, so what's happening to the natural log of u as u goes to 0 from the plus side? What's happening to the y value? It's going to negative infinity. So it equals negative infinity. Okay, so the idea is start with the inside. You've got to know what these functions look like. So if you don't know, you should just graph them. So let me just draw the graph in the natural log function right here, because we had to use that. So when we graph y equals the natural log of x, it looks kind of like this. And so it's, coming in, but it's got a vertical asymptote right here. That's really what that. You can see that it's getting closer. Okay, so the idea is you look at the inside, and instead of looking at a unit circle here, you could have also looked at the graph, on your calculator. And then you look at what the outside is doing as the inside is going to whatever it's going to. So in this case, sine x was going to 0 from the positive side. And that's the inside of the limit. So what's natural log doing is its argument is going to 0 from the positive side. It's going to negative infinity. Okay, so I believe that's it. Yes, that is it. This section. So I'm hoping that you can do your homework. There will be a quiz coming later this week, so I'll make an announcement about that. And we got a test coming up for too long. I'm going to have a review session next week. And I will do an announcement on that. So take care. And please keep contacting me and let me know how you're doing. So I think that is it. Goodbye, guys. Let me see. Turn off my recording.